Good morning, ladies and gentlemen. Up next, we have a very, very important speaker. His name suggests that he sells things like T-shirts and mugs. Please allow me to introduce Merge.
All right. Good morning, everyone. Anyone been at the karaoke yesterday? I got a song stuck in my head. I know Ethereum's secret. Shout out to Super Testnet. All right, let's talk about Mempool and policy. So this year we had a lot of discussion about that already. There's been some claims that we don't need a mempool. There's been some ideas of having dark mempools to get transactions that currently don't propagate on the network directly to miners. I've seen at least one call of getting rid of all policy rules because who needs that? So I think we've done some writing about this topic this year. Gloria and me had a 10-week series in the Optech newsletter. Some of you might have seen some of that, and we've also discussed that in our audio recap of the Optech newsletter, which now came out as its own separate podcast. It's like 2 hours. If you're interested in the topic, there's a lot of material out there this year already. But let's get into it. So why do we have mempools? And I'm taking audience shouts here too. What's the important thing that a mempool provides to us? One of them. There's like 7. Fee estimation. Cool. Censorship resistance. I like what I'm hearing. Yeah, just propagating the transactions. All right. We can pre-verify transactions when they're already in. When we see them in our mempool, we can verify that we know the UTXOs that are being spent, that the scripts are valid. So when we see it in a block, we don't have to check that again. Yes? Separation of powers. Do you want to elaborate? Right. So the comment was, in Ethereum, we're seeing stuff where people have a lot of power of what gets into blocks. If, for example, mempool.space had its accelerator start, they might have an undue influence on how blocks are composed. So separation of power was the comment, actually, if I didn't repeat that. All right, let's recap. So we have to have a way how users can get their transactions to miners, to block authors, so that block authors can pick them into their blocks. We can pre-validate transactions so that they are more quickly, when new blocks come in, we can more quickly process them. If we already know that everything on the list of the block is valid, we just have to reconstruct the block and can forward it immediately to the other peers. We see unconfirmed transactions already, so we can learn about inbound transactions, and we know what we're competing with if we're submitting our own transactions. We use that also to estimate fee rates, and this all overall facilitates an auction of block space. By being able to know what we're bidding on and the miners having hopefully the best possible selection of transactions to pick from, we can efficiently auction off the block space. Finally, one thing that hasn't been said yet, it helps us with privacy. If you're submitting a transaction to the network and you're only giving it to the peers, it looks the same to the peers as if you had been maybe the second or third hop. You had it before them, but they don't know that you're the originator. They might guess, but they don't know. And nobody else really can tell where the transaction originated. And, shit, I forgot to start my timer. How long am I in? Anyway. All right. And finally, yes, censorship resistance. So by everyone having transactions, anyone that sees that transactions are not getting mined may start to be a miner themselves. They can start building blocks and acquire hash rate and author their own blocks, right? So those are the 7 benefits of mempools that I've identified. So frequently we hear that there is no the mempool, and that is correct. Every node has its own mempool. Every node may receive the transactions in different orders. They might not receive all of the unconfirmed transactions. Some nodes might run with different policies, so they might not accept some of the transactions into their mempool. Sometimes there are two conflicting versions of transactions on the network, so a node might receive one while another node receives another. It would, however, be super great if all the mempools had the same stuff, because just as we identified, if nodes already know about the unconfirmed transactions that are going to be in the next block, the blocks will propagate faster. The fee estimation will be more accurate, and they'll be better able to gauge how much they actually exactly have to pay to be in the next block. So when we talk about the mempool, we're talking about an abstract ideal of what roughly everyone has. And most mempools do overlap very closely. They are like probably 98% the same. You might be off if you have been offline, just restarted your node, or if you're in an obscure corner of the internet where you don't have a good connection. But for the most part, you should have almost exactly the same transactions as everyone else. So what is the problem with routing around the mempool? If we have multiple ways of getting transactions to miners, we lose some of these benefits. The transactions no longer are visible to everyone in advance. Maybe some of those transactions that get included into blocks have undesirable properties, like they take a very long time to validate, or because nobody has seen them before, they slow down block propagation because everyone has to ask back first, hey, can you give me that transaction? I don't have it. So there's more issues. Let's assume, for example, we did not have a mempool at all, and everyone was submitting transactions directly to miners. How would we know where to reach those miners? Maybe we have a set of the 5 biggest mining pools, and those are the IPs we hit, and we just submit it to their API. So what could they do? They could learn our IP addresses and have a pretty heavy indicator on where that transaction originated from. They would directly be able to censor transactions whose patterns they don't like. It would give a huge advantage to established miners, because if you have a list of 30 miners and the top 5 of them are 95 of the hash rate, would you really bother to give it to the last 20 of them? Probably not. You'd just submit it to the first 5. And so routing around the mempool means that mining fairness gets reduced. It makes it harder for new miners to enter the market. It makes it harder for individual nodes to estimate fee rates. And it might, introduce censorship or yeah. It is, however, if this came to appear, so for example, there was a suggestion that we could use Noster for package relay a while back. If that were to appear, that would be a sign that current mempool policies do not serve all use cases of the users in the Bitcoin network. If there are many transactions that do not get to the miners from the users right now, then we should probably address that and amend our policies in our nodes so that we facilitate this transport of the transactions. So why are we so stingy with our mempools anyway and so restrictive? We're in an adversarial environment, right? We're essentially in a network of unauthenticated nodes. We don't know who they're run by, what their agendas are, what they're trying to achieve, and we're giving them direct write access to our memory, right? So if they can just submit whatever they want to our memory, they might crash our node. They might make us do a lot of extraneous computations and then just replace those transactions with other stuff that does even more computations for us. They might waste bandwidth, they might fill up our memory, they might slow down block propagation, and so forth. So what we're trying to achieve with the policy is to facilitate as much possible transport as we can, while also protecting our own node resources. So for one example is, originally the mempool was not limited. So if you got more and more transactions, your memory would just run full, and eventually your computer would crash. And we introduced a mempool limit of 300 megabytes, and that's really where it comes from. Like, you just not every machine can store an unlimited amount of, or no machine can store an unlimited amount of transactions. Eventually, they'll crash, right? So the other reason that is a problem is it is completely impossible to effectively ban a peer that abuses you, because all of our connections are unauthenticated. They just come back with a different IP address and start over, right? So we have to protect our node in some way. And any questions or comments? All right, cool. The other thing that we have to protect is the global resources. So, for example, it costs bandwidth to forward transactions. And if someone has a way of just repeat sending the same information in slight variations over and over again, they're just wasting bandwidth of every single node to ad infinitum. And what do we do to do that, to protect against that? Well, we require replacement transactions to pay more fees. They essentially pay for their bandwidth by both needing to pay a higher absolute fee and a higher fee rate. So they can replace their transaction, they can change their mind and offer something, but only something that is more attractive to miners and that essentially pays more to the overall network. So there's a restriction against just wasting resources. Another resource that is, or two more resources that are globally important are just generally the size of the blockchain, which influences how long it takes to do an initial sync of a node, and, for example, the UTXO set. The UTXO set is a data structure that needs to be loaded from in order to validate all transactions. While it's often misconceived to have to be in memory completely, we only load the parts that are relevant for transactions we've recently seen or that were created by transactions recently seen. So it will degrade smoothly when the UTXO set increases. But for example, the IBD will require more memory to run efficiently, or it'll be way slower if the UTXO set is bigger. So how do we implement all of those restrictions? There's this thing called policy, or just Mempool policy. It is essentially a set of rules that is more restrictive than the validity rules. So the transactions that are valid are a huge body. There's a lot of really weird stuff that you can do with Bitcoin script, but we reduce that to a much smaller body of so-called standard transactions. And some examples of those policies, for example, are the max standard weight for transactions. We will not accept to our mempool and propagate transactions over 400,000 weight units. Why? Because, for example, it makes it harder to build good blocks. Blocks are a bin packing problem. If you have very big chunks, you might have to kick out 50 transactions in order to fit that one bigger transaction in. So really, it would be way easier if the max weight was even smaller. Bigger transactions are potentially slower to validate. We had the quadratic SIG hashing issue with the legacy input types. So a transaction that has a ton of inputs would essentially require quadratic computation in the number of inputs, and larger transactions are more expensive computationally than smaller transactions. Bigger transactions also exacerbate economic pinning. So if you attach a big transaction to a transaction that somebody else is trying to get through quickly, it'll require them a lot more fees in order to reprioritize that transaction. There's other examples like the dust size, or that we only allow one op return with 80 bytes. All of those are examples for mempool policy. And mempool policy is something that is enacted by your node. It is basically subject to your own control. You can change some of those in Bitcoin Core, for example, in the configuration. For some other ones, you'd have to recompile. But generally, as we identified earlier, it is beneficial to have the same settings as other people. If you have a bigger mempool, we saw this, for example, with some Lightning nodes when the inscription craze took off in February. Some Lightning nodes had channels open, and their commitment transactions had lower fee rates than what was required to get into blocks. So they tried to renegotiate with their channel partners, and there were some situations in which they couldn't agree, and one tried to close. And then the transaction wouldn't go into the mempool because it was below the dynamic minimum fee rate. And so the suggestion was increase your mempool size. Then you can have it in your mempool, and then you can CPFP it because you can attach a child. Well, what happens is the parent cannot propagate to the node's peers because the node's peers have default mempool sizes. They will not accept it because it's too low fee rate, and the child cannot propagate because the parent is unknown. And then while the node thinks, oh yeah, I totally broadcast to the network, it's not going to be seen by anyone on the network, and especially not miners, right? So they're sort of lying to themselves, and it's sort of the misunderstanding of, yes, sure, you can change the policy locally, but you have to think about how that affects your interaction with other peers on the network and whether that will actually achieve the thing that you're trying to do. Well, finally, one of the things that we do with policy is to protect upgrade hooks, right? So for example, transactions that send to future witness versions, we do not propagate right now because they're considered non-standard. And we do this protection of upgrade hooks in order to be able to have future soft forks easily by knowing already what we might use in the future that and not allowing that at all right now because there's also usually no sensible way of using it. We enable ourselves in the future to introduce new soft forks. All right. Finally, I wanted to also mention that policy is evolving. So we've had multiple proposals in the recent past and also in the last years. So one of the big topics that you've probably heard about before is package relay, which talks about how to propagate multiple transactions together. So coming back to this example with Lightning nodes being unable to get their commitment transactions propagated on the network, and also the idea of using Nostra as a package relay mechanism. This is a project that aims to allow transactions to include their unconfirmed ancestors in the propagation and have the transaction be evaluated into the mempool as a group. Usually when you receive a transaction, you will have to test every transaction separately into the mempool. So if one of them fails to get in, all the ones that depend on it will not be able to. But if you test them as a package, you might use their overall size and overall fee to determine a package fee rate. And if that's high enough, you will include it into your mempool. There's a proposal to introduce V3 transactions, which will restrict the size of child transactions and count of child transactions. So a V3 transaction would only be allowed to have a single unconfirmed child, and the child would not be allowed to have more than 1 kilo VByte. And what this does is it gets rid of a bunch of the pinning vectors, and it makes it much easier to reason about for people that use these sort of constructions, for example, to close Lightning channels, to like curb the attack vectors and surface. Closely related is ephemeral anchors, which is a way. Yes, sir. Time up. 5 minutes. That's excellent. I'm almost done. All right. Ephemeral anchors is a way of having a minimal size output on a transaction that we require to be spent in the same block. so that it will not pollute our UTXO set. And that way, disintermediate the fee estimation from the time that we create the commitment transaction in Lightning, for example, to when we broadcast that commitment transaction. So we put the effect of closing the channel into the commitment transaction, attach a up-true output on it with a 0 value, and that has to be spent in the same block. And the second transaction that spends this ephemeral anchor, the child transaction, that is what brings the fee. So now you can have the commitment transaction committed to by your channel partner at the time that the update of the channel happened, but you determine the fee rate when you try to enact it. Another one that I'm super excited about is cluster mempool. Cluster mempool is a way in which we envision to re-architect how we store unconfirmed transactions in Bitcoin Core. The idea is to instead tracking them by ancestor sets, where every transaction keeps track of all the unconfirmed ancestors with it, and therefore we might have overlap in various ancestor sets when, say, a child has a parent and a grandchild has both the child and parent as its ancestors. We would track the same transactions multiple times. In a cluster where we track all of the related transactions together as a unit, we would just put them all in one cluster. And this has some benefits, for example, to how we drop transactions when we have to prune because they exceed the size. It'll make block building much faster, and it might make it easier to reason about package relay and some other networking mempool topics. Finally, we've seen a lot of discussion lately on the Bitcoin Core repo about dropping the up return limit, mempool full RBF, and disabling bare multisig propagation. So these sort of topics are totally on par and should be discussed if people feel like that improves things. I would just say, as long as people are using stuff, for example, for many years, people did not use bare multisig, and probably last year we could have just flipped that flag that we no longer propagated. But this spring, some people felt to use it again. So we don't really want to police what the network does. What people do in the network should be up to them if they pay for it, as long as it doesn't actively harm other use cases and users in the network. So we're trying with policy to sort of have a split path between allowing as much as possible while curbing detrimental and adversarial behavior. And it's an open conversation. Just please, if you're participating in these discussions, make sure that you read what other people are writing and that your comments add new ideas. Or we've had a bunch of invitations by the public to, on Twitter especially, to come comment on what they think about certain mempool policy proposals, and it's led to like 40, 50 concept act, concept knack, sort of no further information posts by people that don't usually contribute in Bitcoin Core. So it's a lot of noise. Please keep it useful. Thank you.
If you have any question, please come to here, to the stage.
Questions, comments? Yeah, if you take 3 things from this talk, mempool is useful. Similar mempools are better than non-similar
Hi,
mempools.
Merch. Do you have an opinion on how we should design mempool policy rules or pick up default not sayings when we do have conflicting use case, for example, with mempool for
Sorry, could you repeat that?
how we should design mempool policy rules or pick up default not sayings when we do have conflicting use case on the network, and keeping the status quo is harming one use case, changing the status quo is harming another use case.
Okay, so I think you're asking about how we pick between 2 conflicting use cases that have diverging needs in mempool policy. I think at the moment we mostly stay with the same rules if there's no clear consensus that it makes things better. I think if there's a much better use case for one of the 2 use cases and it requires some change, I could see either that change getting adopted if it doesn't hurt other things too much. But yeah, that sort of thing should be debated on the mailing list maybe mostly. Maybe Delving Bitcoin, if that takes off, would be a good venue for some long-form discussions. Yeah. Other questions and comments? All right, thank you for your time.